All right, let's dive right into this explainer. We're talking about building full-stack AI applications using anti-gravity and Claude Code. What if I told you that you don't need to know complex syntax to build a $10,000 application anymore? Seriously. We're moving away from simple theory and stepping into a highly structured, highly functional way to command AI to just build everything for us. I mean, think about where we were just, 6 months ago? We were spending hours, literally hours, gluing steps together in those traditional node-by-node workflow builders. You know the ones. You'd manually connect a trigger to an action, meticulously mapping out data fields one by one. And yeah, it was effective, but it was so tedious. Plus, you were completely limited by your own ability to mentally map out the exact logic for every possible edge case. Well, a fundamental shift has completely changed the game. And that brings us to this massive paradigm shift. We have completely moved past that one agent bottleneck of legacy systems. Now, we're deploying a whole team of parallel AI agents that can think and act simultaneously. It's kind of like having one chef trying to cook an entire banquet node by node versus deploying a whole kitchen staff working in parallel. In the old way, you had to physically build the scenario yourself. But in the new agentic way, using tools like Google's anti-gravity, you simply tell the system what you want to achieve, and it runs multi-threaded, parallel tasks to build the infrastructure for you. You're just not constrained to one single linear path anymore. So here is our roadmap for demystifying this new ecosystem today. 1. The agentic AI shift. 2. The universal remote, or MCP. 3. The BLAST framework. 4. Probabilistic versus deterministic logic. 5. Styling and UI sniping. And 6. Triggers and automated deployment. Starting off with Section 1, the agentic AI shift. The absolute best way to wrap your head around a system like anti-gravity is to imagine you just hired a 500 IQ intern. Instead of manually building out these scenarios, you just tell anti-gravity what you want, and your superpowered copilot builds the entire architecture for you. It knows your business, it thinks critically, and you can just chat with it to iterate on designs and functionality. But here's the catch. As smart as this intern is, if you lock them in a room without a laptop or an internet connection, they can't actually do anything for you. Which brings us to Section 2, the Universal Remote, or MCP. Because they need to be able to reach out, fetch data, and push updates to your existing software stack, right? And the real key to unlocking this is the Model Context Protocol, or MCP. Think of this as the universal remote that unlocks the AI's ability to actually perform actions in your other apps. It's a standardized way for your AI coding agent to securely shake hands with external services, understand their APIs, and manipulate them just like a human developer would, without you having to manually code that integration yourself. By plugging in these MCPs, your agent is suddenly everywhere. It can seamlessly pull a meeting transcript straight out of Fireflies. It can extract the action items and push them over to Notion. It can create a beautiful dashboard in Supabase, which, by the way, is basically Microsoft Excel on steroids for your backend data, and it can handle app hosting directly through Vercel. You can connect to virtually anything. Oh, and one quick pro tip straight from the source material: try to keep your active tool usage under 50. Giving the AI too many tools at once can really clog up its context memory, which leads to a drop in performance. Just like a human, if you dump too many tools on its desk at once, it gets confused. So keep it focused. All right, moving right along to Section 3, the BLAST framework. This is the core engine of our methodology today. Because when you have an AI that can do almost anything, the single most critical factor for success is how you instruct it. Every successful agentic system touches these 5 precise steps. First, the blueprint, where you gather requirements. Second, links, to secure your MCP and API connections. Third, architecture, where you build strict deterministic SOPs. Fourth, stylize, to refine the UI and UX. And fifth, trigger, to actually deploy those automated functions. It spells out BLAST. This is your master prompt structure. You never ever just ask the AI to build an app. You initialize the project by feeding it this exact framework. Now, the B in BLAST, the blueprint phase, is absolutely crucial. You have to define your North Star before the AI writes even a single line of code. You're establishing the source of truth, where the data lives, and the delivery payload, which is exactly how and where the final result should end up. Listen, the problem you are solving is infinitely more important than the code used to solve it. If the AI doesn't know the North Star, you are going to end up with a beautifully coded app that does the absolute wrong thing. Next up is Section 4, probabilistic versus deterministic logic. So we've got our blueprint, our links are connected. Now we hit the biggest hurdle in AI development. This is honestly where most vibe-coded apps fall apart the second a real customer tries to use them. You see, language models are inherently probabilistic. They're basically just next word prediction engines. Ask a standard LLM the exact same question 100 times, and you might get 100 slightly different answers. But if you're building a $10,000 application for a client, your business logic has to be strictly deterministic. If an automation is triggered 100 times, it must perform the exact same reliable execution 100 times. You absolutely cannot have an AI guessing how to route a customer's payment data. To bridge that gap, we use a 3-layer architecture. And the golden rule here, if logic changes, update the SOP before updating the code. You have to strictly separate concerns. First, you have an architecture layer written in plain text markdown that acts as the unbreakable law of how the app works. Next, you have a navigation layer that simply routes data without trying to think too much. And finally, you have the actual execution scripts. By separating these out, the AI is instructed to consult the standard operating procedure first. That completely removes the guesswork and becomes the gold standard for your app's reliability. That takes us to Section 5, Styling and UI Sniping. Okay, so our logic is rock solid, but we definitely don't want our app looking like a $2 suitcase, right? We want a premium, gorgeous interface with zero cognitive overload for the user. This is where a technique called UI sniping comes in. Instead of reinventing the wheel, we grab existing high-end design components and feed the raw code directly to anti-gravity. Think about how many hours of tedious CSS tweaking this avoids. You don't need to ask the AI to design a modern chat interface from scratch. You just go to code repositories like 21st or CodePen, find a beautifully animated component, copy the raw code, and tell your AI pilot to implement that exact style. Boom, instant upgrade. Finally, we've reached Section 6, Triggers and Automated Deployment. Our 500 IQ intern is done, and it is time to ship it, because it's no use having a brilliant application that only runs when your laptop happens to be open. We use a really robust tech stack to make sure the app runs completely autonomously. Anti-gravity is your visual IDE, your command center. Claude Code is your primary pilot, actually writing the complex systems. When it's time for background tasks, Modal steps in to handle the heavy lifting. Then your AI automatically pushes your front end to Vercel so anyone with a link can view it live. And meanwhile, you have tools like ImageMob or the Nano Banana API, generating automated unique visuals on the fly. The whole shebang. But the real magic happens in the back end with Modal. By deploying to an infrastructure service like Modal, your system can automatically check for new meetings, update Notion databases, or scrape Reddit for viral trends every 3 hours without you lifting a single finger. You just configure the interval once using natural language, and the AI sets up the environmental secrets and the hosting. You could literally be at the gym, and your agentic system is still processing data and making decisions in the background. And for those really tedious tasks you repeat daily, like auditing code, cloning competitors' websites for inspiration, or running massive SEO audits, you can actually turn those into permanent automated Claude skills. You literally just create a / command in your terminal. You tell the AI the exact steps it should take, what APIs to hit, and what formats to return. From that moment on, a complex hour-long audit is reduced to simply typing one command and hitting enter. It's a total game changer. So with the BLAST framework bridging that massive gap between natural language and deterministic logic, and the pure power of agentic OS systems at your fingertips, the barrier to creating full-stack software is pretty much completely gone. The technology is here, the frameworks are tested, and the only real bottleneck left is your own imagination. So what will you build next?